Good morning, everyone. My name is Chris Gillis, and I'm the Manager of Applied Research Business Development with Durham College. And Durham College is one of the partners in the Durham Regional Technology Development Site that is part of the Autonomous Vehicle Innovation Network. And I'll be taking over the role of MC today from my colleague Richard Dunda of the Hamilton Regional Technology Development Site, who did that yesterday, and Richard did a great job. So I'd like to welcome everyone to day 2 of the 3rd annual Future of Transportation and Mobility series event, where we are exploring the future of goods movement and the supply chain. And just a note, if you were not able to join us yesterday, I wanted to let you know that Chris Keefe of Arrigo gave an enlightening keynote on the application of connected autonomous vehicles in the airline industry. Corey Clothier of Stantec gave a global panoramic perspective on how connected autonomous vehicles are rolling out, and our panel, moderated by Gaddick and representatives from Loblaws, Purelator, and McMaster University, exposed a number of really interesting key issues going forward. And I just want to remind everyone that these proceedings are being recorded, and they'll be available on the CITM and Durham RTDS websites after this event. So today's theme is that of the role of data, analytics, cybersecurity, and AI in connected and autonomous goods movement. And so to kick off day 2, it's my pleasure to introduce Cyrus Tahani. Cyrus is Chief Digital Officer of the City of Hamilton, who will deliver the opening remarks for today's proceedings. So Cyrus, the stage is all yours.
Thanks, Chris, for that introduction. On behalf of the City of Hamilton and Mayor Fred Eisenberger, it's my pleasure to provide some brief opening remarks and welcome everybody to day 2 of the Future of Transportation and Mobility Conference. I guess though it was only last January, seems like much longer ago, we had gathered at Hamilton's Warplane Museum for last year's conference. Amazing venue to talk about that future of mobility in the presence of aviation history. I won't dwell on the good old days, where you could speak to people in person and shake hands and exchange business cards. But, instead, I want to congratulate the Center for Integrated Transportation Mobility, and all the event partners involved today and over the past yesterday and tomorrow for moving this conference to a virtual format. And I had a chance to catch some of yesterday's agenda and some great discussions and presentations, and I know there's more still ahead today and tomorrow. Hamilton, of course, really proud to be host to one of the 6 AVEN regional technology development sites. I think it's obvious that would never have been possible without the great work and effort by the entire team at CITM and our RIC Innovation Factory, and of course in collaboration with AVEN and the province of Ontario. I know the city's been working closely, myself included, with the team at CITM, and that partnership, I think, speaks to the broader innovation mindset here and in Hamilton. I have a pleasure of chairing our City Smart Community Working Group. We have partners at the table that include, obviously, CITM, Innovation Factory, McMaster University, Mohawk College, our Hamilton Utilities Corporation, HCE Telecom, our Economic Development team, and a few other partners. And this group works collaboratively to look for some of the innovative opportunities, in line with some of the topics that are being discussed at this conference and how that can be supported and expanded. The connected vehicle testbed sites, and even the current development plans for a remotely piloted aviation system, or more commonly, I guess, drone research park, are just some of this innovation work that's occurring amongst this partnership. And I think it's this collaborative partnership ecosystem that exists here in Hamilton that I feel will be a key factor to help support the development, testing, and piloting of these rapidly changing supply chain landscape and the opportunities for both for business and economic growth and diversity that it presents. Hamilton, obviously, if I can go on a little bit of a spiel, is a key gateway for goods movement. We're located obviously in the GTHA, the center of the economic hub. We have access to a wide range of transportation, passenger, e-commerce, heavy, project, cargo, commodities. We're one of the only handful of Canadian cities that has all 4 major transportation modes within our municipal boundaries: road, rail, air, and port. We're truly a multimodal transportation center. We have the airport, we have the port, we have CP and CN rail lines, and intermodal facilities with connectivity to all the major highway cities, which really makes us well positioned and also drives us to make sure that we're thinking about what the future supply chain landscape looks like. Now, on top of that, you layer being home to McMaster University, which is Canada's most research-intensive university. We have Mohawk College, one of the top industrial and applied research colleges in the country. We have McMaster Innovation Park, Canada's premier research innovation park supporting startups, businesses, and research. There are a broad range of opportunities around autonomous goods and services movement. Hamilton, I'm proud to say, was also named one of the top 7 communities by the Intelligent Communities Forum for 2020 for its work across multiple domains that include, connectivity, knowledge workforce, innovation, digital inclusion, community education, and engagement and sustainability. Of course, all this work is not without its own challenges. I'll be the first to admit that working sometimes with a municipality can have its own unique set of challenges, whether it's legal, privacy, cybersecurity, or change management. These are all part of the learning curve associated with any smart city or CAV-related technology deployments. But I think also with some of these challenges come some really big opportunities, whether it be pilots or living lab collaboration opportunities, improving communications, improving services for citizens, getting better data, making sure that data is secure, or even creating education programs to train and develop the required career pathways that we're going to need to deal with this new future technology that's coming our way. Maybe some of these partnerships can include tech companies and already do, utilities, academia, and industry. And all of those kind of coming together will be a critical component for our present and rapidly approaching future of transportation and mobility and autonomous goods and service deliveries. So with that said, in closing, I want to thank for the opportunity to kick off today's exciting agenda, and I'll pass things back to Chris. Thanks, everyone.
Thanks so much, Cyrus. I really appreciate those opening comments, and specifically to highlighting the whole idea of collaboration. I think the whole Autonomous Vehicle Innovation Network is really all about that, and certainly this event too. So I just have a few housekeeping items to cover very, very quickly before I introduce our keynote. I just did want to remind everyone that this event is being presented by the Innovation Factory Center for Integrated Transportation and Mobility, which we refer to as CITM, and they are the Hamilton, Rick. And then there is Ontario Tech, the Spark Center, and Durham College. We are the Durham Regional Technology Development Site, and of course in collaboration with the AVIN, the Autonomous Vehicle Innovation Network. I just want to remind everyone that all of today's presentations will take place here on the main stage, and that's where you are now. And if you have any comments, please put those in the stage chat, and that's to your right-hand side. You'll see the word stage there. Also, just a reminder, speaker bios and all the event information is on the event website, so please check that out and it'll allow you to connect with people you may wish to network with. And also a thank you to Solano, who is live streaming the event, and a reminder, if anyone is enjoying this from a live stream, we'd ask you to please feel free to go to the website, the event website, and register for the event. So now it's time for our keynote, and that's titled Automation and the Internet of Things, the Death of the Security Perimeter. So it's my pleasure to introduce Eric Matthews. Eric is Chief Technology Officer and Co-Chief Cyber Strategist with Parabellyx Cybersecurity, who will provide you with, I think, a leading edge lens on where cybersecurity is and where it's headed. So Eric, the stage is yours.
Good morning. Thank you. Great to have everybody here. I can't see any faces, but that's the nature of how we're doing things right now. I'm going to share my presentation here briefly. I just have to get that up. All right. So it's great to see everybody here. Like Chris said, I'm Eric Matthews. I'm the CTO and co-founder of Parabellyx. We're a Toronto-based information security consulting firm. I've been involved in IT security for about 20 years, time's been mostly split between doing penetration testing work. Sometimes people call a white hat hacker, where we're breaking into applications and networks to test security systems, and also security architecture and implementation, where we work to secure the same networks. We started Parabellyx a couple years ago, recognizing that there's some significant changes going on in IT right now, and I think we have a good pulse on that to help organizations better achieve their security goals through that shifting landscape. I know today, I think in this conference, we're primarily focused on automation and autonomy, and that's an important area of development in computers and technology. But realistically, the trends that we're going to talk about that surround autonomy and the Internet of Things are prevalent in IT in pretty much every area. I'm going to go ahead and walk through how the fundamentals and this fundamental shift in IT really kind of manifest as we work through technology's growth and through the next phases. So to start, autonomy is really interesting. It has become pervasive in society, and I was reading a book recently by William Davidow called The Autonomous Revolution that has made the claim that autonomy is the third significant phase change of human society. That is a pretty profound statement, but he claims that we went through an agricultural revolution, we went through an industrial revolution, and the autonomy revolution is just as significant to the future of humanity and technology. So with that said, we may be at the leading edge of what may become the most significant changes to human society in generations. We want to keep our finger on that. We can't always predict what's going to happen next, but really working through that and being on top of it is the best approach we can take. This really brings us some new challenges and some new risks. People here will already know this. You guys are aware of automation, but I just wanted to play this briefly while I talk. I think autonomy has been viewed in the past as something that is coming, something that is in the future, and I think this is not going to work. So we're going to go ahead and just talk about it. There we go. So realistically, autonomy is already here. We see it in the environment. We see it in the around us every day. And it's not distant future. What we have on the screen right now is, I think, something everybody here is familiar with, but this is a video. I'm not going to play the whole thing. We'll just look at a few seconds of a vehicle driving itself with zero assistance from a neighborhood in San Francisco to a neighborhood in Los Angeles. Obviously, that's not the mainstream right now, but it is available to the public. People are using it, and it will become prevalent in the near future. And autonomous vehicles are obviously not the only target for autonomy. I think they're a very visible and socially important aspect of it. So they serve as a bastion for that in the public eye. But frankly, they're coming sooner than most people realize. So there's an idea I'm calling pervasive autonomy. That means that autonomy and the proliferation of small devices, or the Internet of Things, is building itself into every aspect of society and becoming more and more invisible as it becomes smaller and more capable. This concept of pervasive autonomy is characterized by a couple of independent factors. Number one, the increasing independence of action. This is significant because devices will become increasingly able to make critical decisions and control more and more critical infrastructure. That happens today with some oversight and operation from human operators, but in the future, that's going to move into more and more unsupervised decision making. It's also categorized by greater connectivity. Devices spread across the world, distributed networks, public spaces. Often these devices will be wireless, they may be out of sight. And finally, a distributed deployment. And what I mean by that is devices will become smaller, they will become more mobile. The application components will distribute out to the edge of the network. And in addition to that, any core services we have will likely be distributed and deployed to cloud environments. The mix of these three ideas really provides us with huge productivity benefits. They're all driven by an increase in capability. but they also multiply the potential risks posed by these systems. So for the next little bit, we're going to dive into some risks and approaches for addressing risk in this kind of environment. Parts of this discussion will be a little bit technical, but I'll try to keep it at a level where we can talk about it regardless of your background. So right now, security is a pretty significant component of the IT industry. 2020 was a hallmark for IT security, obviously, with the changes in how we all do work and how we work from home and how we present at conferences. There were over 4,000 publicly reported breaches. These aren't, there's obviously probably significantly more than that aren't publicly reported, but these are the big ones. Over 40 billion records exposed. And 2021 probably will be the first year we exceed $1 trillion in global cybersecurity spending. Autonomous and distributed systems are the next front. They really are, and that is becoming more and more clear as they become more prevalent in society. Another component I already mentioned of that, and this is throughout IT, it's not just in autonomy, but it's an important component to be aware of. 97% of businesses currently or plan to use cloud resources. 70% are currently shifting a significant fraction of their computing power to the cloud. That means we need to have a different approach to security, and the mindset of security means that we can't rely on our old-fashioned infrastructures. We need to start thinking about cloud security, how it works in exposed networks, and what it means to transport and store data on untrusted locations and in public. So the old model of network security, and honestly, this is taken from a current security vendor's sales material, is to have your servers, your people, your computers behind a firewall. You stick everything. I call it the old crunchy, the old eggshell, or the crunchy shell. You build a hard perimeter, and then everything on the inside is just sort of trusted by default. This is the old model, frankly. Your 90s IT guy probably still advocates this, but hopefully people have started to understand that this is in the past and to a large degree, especially prevalent. Excuse me. Especially obvious when we go into IoT and autonomous devices, anything that's distributing their power to the edge. Imagine we get a fancy new thing. Your 90s IT guy might just say, plug it into the switch. It's on the network. It's fine. Don't worry about it. And this is probably still prevalent in areas, even in areas of automation. It might include in manufacturing. It might include areas around other areas that have an internal network that you can trust. Sometimes maybe the 2001 IT guy says, let's make a separate VLAN for your IoT or for your automation or for your SCADA products. That's fine, and there's nothing wrong with network segmentation. In fact, the smaller the network segment, the better. But the future is microsegmentation or zero trust. And fundamentally what this means is that every device is its own security bastion. It doesn't trust anything around it, and it's pervasively connected. This is really how things are moving. When we see devices that are mobile, we see devices that are independent, we see devices that can move in between networks and use public spaces and public networks. Each device has to serve, in a manner of speaking, as its own security principle. So I call that the death of the security perimeter. And fundamentally, the future is remote, the future is cloud, the future is internet accessible, the future is distributed, and the future is public. That's pretty profound, I think, a shift in how we do security and how we do IT. It's important to recognize that the core of the network, the sort of internal component, isn't going away, but it's going to be a significantly smaller fraction, and in some businesses, it's going to be zero. So what does that mean to have pervasive autonomy? How do we, how does that change security when we ask the question, what does it look like to have a secure environment in this? What are the changes? Why are we addressing this? And I think there's a couple of points here. Number one, distributed endpoints, something we talked about earlier, they increase the attack surface significantly, meaning that instead of a server with a couple of terminals that are on a trusted network, you have, say, tens or dozens or hundreds or maybe even hundreds of thousands of devices deployed in a public space, in the field, on a street corner, in every conceivable industry. In addition to that, autonomous systems increase the sensitive data and the value of that data loss. When a system is able to collect enough data to make intelligent decisions about its environment, it clearly has a significant increase in both the quality and the quantity of the data it's storing. Also, independence of action means that these devices create risks to health and safety to other areas. They're able to do things, and that's their purpose, and that's the goal, and we want to enable that as a security person. My job is essentially to secure things in an enabled way, so that we can provide, what we call enablement, to be able to say to a business or to a designer of a new system, to say, yes, we can do that. Here's how we do it securely. And finally, obviously, I think we mentioned extensive cloud deployment changes the application residence and sovereignty. The idea of data residence and having the data, quote, on our network is fundamentally challenged, and something we need to continue to address. So, talking about these increasing connectivity, I'm going to dive into a little bit more detail on each one before we talk about the solutions for them. But increasing connectivity is really challenging. It may be deployments of 5G, it may be mesh networks, it may even be like personal area networks or things like that. Bluetooth, Zigbee, all of the other solutions that are out there for various kinds of IoT devices. But realistically, what they do is they expose greater attack surface. Again, the likelihood that these devices are discovered by attackers is increased dramatically. Whether that's a smart meter on your home, which is a great example of increasing the attack surface. Suddenly you've gone from a device that used to just be a set of mechanical switches and dials. You really can't attack it in any way other than hitting it with a hammer, to a device that's doing a meshed network to communicate its behavior and maybe even take commands from the utility authority back via some sort of backhaul on a Wi-Fi or 5G network. That increases the attack surface and the ability for an attacker to target these devices significantly. Again, increasing independence drives more and more risks. There's a couple of great examples of this. In fact, 3 weeks ago, there was an attack in Florida against the Oldsmar water treatment facility. This was in the news. You've probably heard about it. But an attacker managed to gain access to a water treatment plant that did water treatment for drinking water in a town in Florida. And they increased the sodium hydroxide concentration in the water by 100 times, which is potentially lethal. That fortunately was noticed by the staff at the water treatment plant, but the ability to execute changes like this remotely using digital systems, using remote connectivity, the likelihood is that it was somebody overseas, that we're never going to find out exactly who it was. That's pretty profound. That you can, and in this case, I understand that there may have been some limitations built into the pumps and things that may have prevented that. But regardless, the fact that this even was a possibility is pretty profound and worth discussing in more detail. Beyond that, distributed deployment. Again, we talk about cloud, and I'm going to keep bringing it back to cloud because this is what we talk about every day at Parabellyx. We have every business we're working with, every business that we see is every organization that we see, whether it's municipal, whether it's research and manufacturing, whether it's universities and everything. It's all distributed, and the pandemic has only accelerated that dramatically. Cloud systems have some unique risks. They do expose, they use untrusted networks, they store data in untrusted locations or somewhat untrusted locations, less trusted anyway. And this exposure of that data is often done using programmatic means instead of a like a long trusted concept, like say an SCP server or something that's been used for 25 years, as we might do on the internal network, or NTP or Windows file shares, SMB shares. Now we're seeing those done with APIs that are custom developed. There may be web components associated with them. Those have significant risks because we're exposing data via custom code and things that are newly developed and have to be fleshed out. Those standards are continuing to develop, but we'll keep an eye on that in the industry. So there's a couple of scary things that we've talked about so far. So, security seems daunting. What do we do, right? What are the solutions? That's going to be the question. That's what everybody's here to see. So let's talk about how we come to solutions. First of all, when we're coming to a solution, we're fundamentally trying to, I think the most important thing, the thing you can't overlook, is addressing and understanding the threats. You really can't develop a mitigation strategy or any capability of fixing security solutions until you've understood your threat factors and your vulnerabilities. So understanding these threat vectors, we look at a couple of areas. This is specific to autonomy and pervasive autonomy and the Internet of Things. We see some areas that come out. Number one, malicious intelligence is a risk. Data security attack is a risk, and we'll talk about each one of these in a few minutes. Code security threats is another area I'll talk about. System security and endpoint hardening is another one, and then cloud environments in general. When we're approaching a unique environment, we often will do a threat risk assessment, a TRA, and there's a couple of standardized processes. In fact, the sort of world standard for threat risk assessment came out of the RCMP in Canada and is used worldwide, and it's one of the methodologies we employ to help organizations understand their risk profiles when it comes to various different kinds of IT systems. So one of the other things that I want to really emphasize, and this is probably not new, but it's important to build this into your mindset for security. If you are in charge of electronic systems or of IT in general, or you're worried about those, it's really, really important to understand that security is not something that you can bolt on. It's not an addition. It's not something you do after the fact. You don't get to do that anymore, especially in this new environment of zero trust, distributed networks, autonomous endpoints. Adding security after the fact isn't really even practical anymore when you have remote and distributed endpoints. You really have to design for security, you have to architect for security, and you have to develop, and that means software development for security. Security is not buying a new tool. So going into a couple of the specific areas, this is one of them we talked about in our threat list, and data security is significant. When we deploy these solutions to endpoints distributed around the world, we have significant data security concerns. The data may be within these local devices distributed everywhere. Attackers may even have access to those devices. They may be in their home or in their car. They may have time to inspect and build attacks against those devices, maybe even months or years. They also have potentially electronic access to data. Again, we use the example of a vehicle. That, everybody has the vehicle in their garage. They can take as long time as they want with it. They also have electronic access to some of that data. They may have an app that gives them an interface to their car. Their car may be communicating to the network via Wi-Fi or other things that they can get in and snoop, depending on the security of that platform. And there's also physical security, meaning in the past we treated physical access to a device as essentially breaking the device. The typical advice 20 years ago was if the attacker has physical access to your machine, game over, it's done. But we can't afford to do that anymore. That's not a realistic approach, because the attackers do have physical access to autonomous systems, and that will not change. So what do we do about it? I think strict control of endpoint data is one thing that we have to keep in mind. We need to be, first of all, again, awareness is something we talk about a lot, aware of data locations and types. Those data locations and types is something we have to really put our finger on. Robust authentication and access control of data is another one, making sure that only the correct people have access to the system. Beyond that, we have data encryption, and this is of increasing importance, even in your standard IT systems. I think if you have a diligent IT staff, probably your laptops are encrypted, your servers, your data stores, your databases, and different types and levels of encryption have different advantages and drawbacks. We don't really have time to go into the details, but in an autonomous distributed device, we want to be able to encrypt the local data. What that can be done using cryptographically secure controls that use, for example, keys that are embedded into hardware chips. That increases the difficulty of breaking that encryption to the point where it's usually not practical for almost any attacker. And then we also have encryption in motion, which is essentially the transport encryption for your devices to try to send data back to the networks. This is again true of everything from websites to laptops. A traditional solution would be like a VPN. This is something that's still viable, but it's not great. A better solution is to just build the idea of the software only, that it only ever functions with encryption. The basics of like a modern version of TLS, which is what is powering our chat today in the secure web and HTTPS, is perfectly adequate. TLS is the newer versions of TLS. Let me be really clear about that. The old versions are pretty bad, but the newer versions of TLS, like TLS 1.2, 1.3 especially, are very secure and have perfect cryptographic, perfect forward secrecy, and some other controls like that help build that security in. So even if you have access and pervasive access to a device, it's very hard to break or impossible, and with current known techniques. Malicious intelligence is the other area that we identified. What does that mean? Well, autonomous systems are able to make decisions based on potentially malicious or modified inputs. And with their power, we have the incentive of users to fake those inputs. A couple of great examples here are I think the Stuxnet attack in Iran was a great example of this. Stuxnet was a malware developed by the Western governments, probably Israel, but that targeted Iranian nuclear power plants. It was distributed globally and infected computers all over the world, but its primary goal was to mess with the input-output cycle of centrifuges in Iranian power plant and uranium or plutonium. I forget, uranium or plutonium refinery plants. And those fundamentally sort of took the inputs and gave them false data. So these sensors were reading that they were under speed even though they weren't, and they tried to accelerate, and they would accelerate to the point where they would be physically damaged. And there's some reasonable evidence that this actually was successful, which Stuxnet is one of the most remarkable pieces of malware ever written, in my opinion. And I could talk about it for half an hour, so I won't. But what do we, what does that mean? Do vehicles? Another great example is the Tesla phantom braking issue and other autonomous vehicles. They see a shadow in the road and they slam on the brakes. A potentially malicious one I also saw was a user putting up a road sign that said speed limit 180. And if the car reads that and just goes ahead with it, it's going to try to drive 180 on a residential street. That's very inappropriate and extremely dangerous. So what do we do about that? Well, we really have to design the systems for validating their inputs and outputs. A great way to do that is redundant automation, essentially checking multiple things. You may check an input sensor for this device, but you may also check, for example, a different kind of sensor, an optical sensor or a camera that can confirm that setting. Redundant sensors is essentially the same idea. And then you have fail-safe mechanisms and deny by default profiles, where you can build some hard limits or some configurable limits, if it's appropriate, into this software. So in your Stuxnet example, you may, if you're a uranium centrifuge developer, you may have thought to build in a maximum RPM at which you can't surpass, and then you can't be damaged by this malicious input. And the worst that happens is you wreck a batch of production. That's true of obviously any manufacturing and any other types of controls. The next area that we talked about was code security. Code security threats sounds a little esoteric, but it's a fundamental type of attack, and it's the sort of stereotypical attack that we think of when we think of a computer virus, a computer exploit. These are fundamentally tackling code security in a way that they're looking for vulnerabilities, they're looking for mistakes, and they're looking for oversights in the actual software code developed by the person who, the software developers who wrote the system. This sometimes you hear called buffer overflows. There's different kinds of attacks, obviously, you know, buffer overflow, heap spray, etc. But these are fundamental to the development of the software. And code security really is inherent to the system. It's very, very difficult to add solutions to the top of a system that's already insecure. Not impossible, but there's you know, limited viability in a lot of those solutions. So fundamentally, our solution is to ensure that there's code security throughout development. And we, Parabellyx, we work with customers often in helping them develop a secure development lifecycle. And what that means is, number one, you build with security in mind, and that security is built into the software in layers as it's appropriate. This can include validating inputs. It can include doing work on controlling things like buffers and memory usage. You can also use secure frameworks that have memory protection controls in place. It also includes some other areas that we strongly recommend. There's automation that we always recommend. And automation, again, it's funny to talk about autonomy helping control the security solutions of autonomy, but it really is. We use autonomy all the time to help make processes more reliable, number one, and help make sure that processes are followed consistently. And using that automation, we can build our software development build cycle with automation in mind, and then include code scanning and code review controls, checkpoints, and actual tools in that process. And that's great. Code security tools, they're not flawless, but they're one of the most powerful ways to ensure that code security doesn't become an issue in an application, because they essentially can crawl through the source code, and you can have it do it on every build in an automated pipeline, a CI/CD pipeline, and that code security software can then be the arbiter or it can identify specific vulnerabilities and issues in the software, and then that allows the developers to fix that prior to having the software even finished. And then we also recommend, and we conduct a ton of these, is security audits on whether it's full applications or pieces of applications. And this is essentially looking from an external view. What does an attacker see? What are they able to do? And code security tools aren't perfect, so they're not the end all. And sometimes there's end-to-end logic flaws, there's authentication issues, or session issues that may only be uncovered by these kinds of audits. And so, you know, regardless of whether, you know, we do it or there's lots of vendors out there that do that, but this is one of our core services, is this kind of periodic or manual testing of whether it's web applications or thick applications or other kinds of software, mobile apps even. That's something that is valuable to the life cycle of software. Another area is system hardening threats. So attackers often target default services. They target the system itself. So we may have built this fancy new automation code, but we may have, say, wanted to have an external API, and we realized we needed some software to do that. So we installed, I'll say, like Nginx as a web server or Apache. And those services themselves are potentially subject to vulnerabilities. They're also potentially subject to configuration or issues with their platforms themselves, whether it's Windows or Linux or other kinds of platforms, whether it's say a hardware driver, and sometimes it's as simple as leaving a default backdoor password on systems. And it's a little bit amazing how common that is, where a company will spend thousands of dollars or millions of dollars securing a piece of software, and then the integrator, who's unrelated to the company, goes to install it in the field, and they've left the backdoor password as just password or something like that. And sometimes those are even discoverable by attackers to decompiling the code. So they're a real risk, and we do see those in the wild, even in automation, but also in every other area of IT. So what do we do about that? Well, default to secure is a common phrase that I use, when talking to customers. We want to establish a repeatable and secure configuration. We want to make sure that when you're deploying something, if you're deploying one of something, that you've gone through checks and carefully evaluated something, and if you're deploying many of something, that you build one and you establish that sort of process and maybe a way to compare them to other builds, and then you're able to go out and build that in a repeatable fashion using some means of automation. And that includes, maybe testing or spot checks to be sure that those aren't overlooked. Finally, cloud security is another area. Keep bringing it up, but it's so important to the modern IT infrastructure. Distributed platforms, cloud. All of your central control points, all of your internal systems are moving to the cloud, frankly. And I think most businesses have said that they're intending to have almost all of their computing resources in a cloud environment. It's cheaper, it's faster, it's more reliable, it's more redundant, and it just has so many advantages. It's hard to justify, except in certain circumstances, but in general, it's hard to justify having a expensive building full of expensive metal with air conditioning and staff and all that other stuff. So realistically, what do we do there? I think in cloud, we have a couple of areas. You can't focus on the perimeter anymore. You don't get to have a badge reader that prevents people from physically accessing services. Now, your cloud security vendors generally have reasonable security, but how do you focus on your own applications in the cloud? A couple of areas that come up in this are identity management, authentication, authorization. Those are super important. And then application security. Again, it comes back to the same thing, but these applications are now, instead of just a component of the infrastructure, are the sort of arbiter of all of the access. They have all the data, they control all the data. So the application that you've developed to go into the cloud, or that you purchased to go into the cloud, is even more core than it was before. And then a couple of other things that I will continue to mention. Logging and monitoring is areas that are hard to overlook. That can, even in areas of automation, but also in general IT, logging, monitoring, understanding that is significant. And then automation, use automation whenever possible. If you can automate a deployment, it's better, because then you can do it again later and it's the same thing and you know that there's no difference. Even if you find security issues, you can go back to your automation and find out why they're present. That is a significant advantage. But you can also use automation for continuous improvement, and that's pretty great when it comes down to how continuous improvement, like what is the process of maturity? And when we look at environments, we talk about their process maturity sometimes, and I'm sure people in manufacturing have heard of this, but repeatability and then a focus on continuing improvement are hallmarks of a mature process, and that really speaks to security as well. If we can build a repeatable, automated process that then enables us to evaluate what we're doing and continuously improve, that's absolutely the best way to approach security. So I mentioned this already, but don't forget monitoring and logging. It's very important, and it can mean anything from an automated activity. For example, in our water treatment plant, if anybody changes the input of any kind of chemical, that should go to some kind of alert. That shouldn't happen without somebody noticing. And in this chemical plant, they weren't doing that. The only reason that they found it is somebody noticed, just happened to be looking at the screen as the person was clicking buttons. That was a fluke, and they got lucky, frankly, that nobody was injured. Logging and monitoring is so important, and automated systems don't reduce that, they increase it. And so number one, logging and monitoring actual IT components like authentication, system changes to the fundamental system, especially on these distributed endpoints that are often a sort of fixed device. They're not something that you're installing software on and patching often. Having a good idea of when those are changed may be critical to the security of the platform. And then, like I said, critical automation activities themselves, and what that means when, for example, somebody updates the software on a vehicle, or when somebody changes the parameters of a chemical delivery device, or there's obviously endless examples of that. So everybody here is, well, many people here are probably saying to themselves, but I don't build solutions, I just buy them and deploy them. Right. Yeah, that's exactly what the problem is in the industry right now, I think. And so we'll talk about that a little bit, because when you buy an endpoint, when you buy software, when you buy some sort of solution, a lot of times you are, as an IT manager, as a director, as a CIO, whatever your role is, you're purchasing products. You're not necessarily developing them. You're not building them. So what do we do? What do we do about all the stuff I just said? Fundamentally, buyers of purchasers of products need to hold the vendors accountable, and that means that probably need to include these general requirements in whether it's an RFC or an RFP or just a contract. Demonstrate to us that you've done your code security. Demonstrate to us that you've done your logging. Demonstrate to us that you've done your update process. Understand the life cycle and the end of life for devices. When will they stop being supported? If they're not supported anymore, you have to have a methodology for understanding that end of life and replacing those products if practical. But the reality is vendors get away too much with saying, yeah, we're secure, don't worry about it. We do good security, it's great. There needs to be more concrete requirements around that, whether that's demonstrating that they have security audits, talking specifics about their secure development pipelines, having third parties come in and check those. There's a lot of different ways to accomplish that, and probably all of them are appropriate, frankly. And also establishing a baseline of legal liability is important. Because the vendors need to be held accountable for these, because that's the only place you can secure these. There is no such thing as bolt-on security in this remote distributed environment. You don't get to add a firewall and an IPS and a spam filter, and the old-fashioned IT security controls. They're not really part of the thought process when you're deploying endpoints to the edge of a network, or when you're deploying an automation point in a factory or another environment like that. Your ability to control that is much more limited. So it's fundamentally on the developer to get to that, and you have to hold them to that. So I'm just going to do a quick recap. A couple of areas that came up often in everything we talked about, or most things we talked about, are these. And if you only take away 6 points for what your requirements for security are: robust authentication. Obviously, we talked about that, but that's so important in distributed and cloud environments. Data encryption. It should be employed everywhere with any sensitive data. There shouldn't be unencrypted systems. And the more accessible those systems are, the more encryption is necessary. System hardening obviously goes without saying. I think that's been a trend in IT security for years. That does apply to everything from IT systems, laptops, all the way through to autonomous endpoints and sensor nodes and things like that. Secure software development, I think there was a big focus on that here talking about it, but it can't be understated. It's really a core of this environment. Monitoring and logging, again, you gain a lot of insight. You really need to know about that, and that can really help you develop a secure process and continuous improvement. And continuous improvement, obviously, is the last one. So building these things together, you can build a flow of having secure by default, having secure installations, and then having a program of continuous improvements for security. So closing. Security isn't a destination. There's no such thing as perfect security in a system that works. We can get pretty close, but if you build the system very carefully, but it isn't perfect. It never will be. So understanding that security is a mindset and it's a process. That means that developing by security, deploying securely, and operating systems with security in mind is something that you have to sort of continuously focus on, because security will continue shifting. Those aren't big changes. I don't see, as we move into automation, obviously there's a shift as we moved into pervasive and remote deployments, Internet of Things, and work from home and bring your own device and all of those other general concepts in IT. We see security continuing to shift along with those. And I think we'll see some security shifting as solutions become more and more autonomous and more capable of really independent work. But we can keep our finger on it by focusing on continuous improvement and making sure that we've got a good idea of what those systems are doing, how they're deployed, and making sure that they're brought together in a secure way as possible. thank you all for sitting with me for a half an hour. We do have a little bit of time for questions, I think. So I'm going to be open for questions. So I have a question here. The question is, how does cybersecurity parameter affect aftermarket in the auto industry? So autos are, again, they're a type of autonomous endpoint, and they have some significant cybersecurity challenges. So building a computer system in an auto, whether it's part of the entertainment console or whether it's part of the drivetrain, I think, there's obviously some security there, but there's almost nothing stopping a vendor, a vendor or a third party, a customer, from replacing that software. There's maybe that hardware, depending. There's ways to do that, but there's potentially legislation going in about right to repair and some of those other concepts, which may break some of the ideas about trying to lock in software on a specific device. So there's a little bit of a give and take when it comes to that. I think aftermarket components in the auto industry may be more challenging in an era where there's computer control of everything. That may functionally break a lot of things, but it also may open a whole venue and field of third-party componentry, and that's a real challenge, because if your fancy, I'll say Tesla just because it's a known brand, but if your fancy Tesla crashes, and then you crack the hood open and realize that you've got a third-party piece of software in there, it wasn't really a Tesla that crashed. Tesla made the wheels and the seats, but the autonomy may have been from a third party. So that's a pretty significant change. But how does aftermarket change? That's a really deep question, but hopefully that I kind of captured a little bit of it there. What are your thoughts on cyber and physical attacks on automated vehicles, such as attacks on ADS? Okay, so there's a couple different kinds of attacks. There's malicious input attacks, which are the example of somebody holding up a street sign. And then there's also cyber attacks against the software itself, trying to, say, break into the communications protocols. Both of those are significant. Vehicles really should be working hard to prevent those attacks. In very few circumstances should a vehicle respond, for example, with an action that can endanger life via a remote message. In other words, there shouldn't be any scenario where a remote message that's coming into a vehicle can cause it to accelerate or brake. That's probably very inappropriate. There may be use cases for that. I know that Waymo's doing some remote control steering and things like that. We'll see how that plays out. The actual attacks sometimes are just proof of concepts, where they're trying to break into a device to demonstrate that they can, control the windshield wipers or something remotely. And again, this speaks to some security issues, some code security issues in those devices, if they're able to get into the system fundamentally and start executing actions that aren't supposed to be controlled by that system. It probably means that they've got some sort of code overflows, like a buffer overflow or a stack overflow, and that concept allows you to access hardware directly and do some other things. I think improving development in some of those areas, things like cryptographically secure communications with your hardware, is a really valid approach, and maybe something that we should be looking into, especially in life-critical and dangerous applications like that. So cryptographically signing requests that go to, say, a PLC or a controller that's executing some sort of important function may be a good approach to that. Another question, are we developing AI that helps security developers? Yeah, there are some solutions in AI that have made their way into IT. Some of the pervasive AI that we see, number one, we see some malware detection using AI. It's fairly immature at this point. I haven't seen any really profound ready-to-go functional demonstrations of that. But I also see some AI in log monitoring. That's probably the most effective area where it's working, and it's working in to help us digest a large volume of information logs of reporting, and say you have a whole IT environment that's collecting logs to a central location, you can use some AI tools that will help identify anomalies in that behavior, which can help you uncover attacks that may have been invisible from a rules-based engine in the past. And in development, I think there's some work right now, and I don't think it's very mature at this point, but there's some work on doing code security scanning as a general concept. Instead of, right now we have a rules engine where we say, you know, here are 600 known attacks, we're going to scan for those, and some of those are very conceptual so that they can catch a lot of things, but that fundamentally means that those developers can there's some development work in the future toward AI that can help do that in a little bit better fashion. Sorry, I just got a note here that we're running out of time here, so I want to say thanks for everybody. Sorry I didn't get to the last couple questions there, but if anybody has any questions, my contact information's on the screen, and I think Chris is going to join us again. I should have turned on my my video here. I was answering questions with my slide
Eric,
up,
and thank you very much. I mean, I think you really did deliver on providing us with a new and different lens, both of you know, the current state of cybersecurity and where it needs to go. And for me, what was fascinating, I was thinking about our yesterday. We saw that the likely rollout is certainly in goods and services, is in airports, airport authorities, and maybe delivery drones. And so what you really articulated here, in my view, is just a whole different way of operating, thinking that airport authorities, communities, and others that will be operating these are going to have to think about procurement practices, regulatory audit, the whole responsibility and the chain of responsibility, and all of that. So thank you very much for that great presentation, Eric.